All right, guys, we're recording. It is January 13th, 2021. It is Wednesday, and we have just completed yesterday our RT210B, which is cardiac A&P exam and lab. Everything went pretty seamless. Okay, it was the first time I had to do two groups because of the class size. For the most part, we did well on the exam. If you didn't do well, then you need to go to the field exam, practice and review. And this is how it looks, just in case you're not sure. This is how it looks. First module, guys, and remember, we go through modules. All you have to do, you don't never have to rarely go over here on the side to find something. You just go to modules. Once you click modules, you'll hear all the mods, okay? A, B, which we completed yesterday. C, which we are in now. Next one will be D, then this is E, F, G, H, I, and J, okay? Now, this is how we work. So you just go to your module. You should see the Zoom link at the top every time to log into my class. Homework assignments and live lectures will be placed in the module as we go. You notice you don't see any live lectures in here because we haven't done any yet. When I complete this one and record it and drop it in, I will drop it in here, as well as there'll be the homework assignments like you've been doing, okay? Now, we finished up cardiac A&P yesterday, and for those who did not pass, you come to this one right here. It's called Failed Exam Practice and Review Work. Okay, you open it up. Notice the first one you have is cardiac practice and review, cardiac A&P. Okay, we don't have the first one because that test was pretty easy. There's not really a practice and review to do for that one. Let's see, somebody's mic is still on. I don't think, I mean, not really, but I'm saying I hear somebody. I don't know what it is. It might be yours. I don't know. All right, so you come to this one here, practice and review, cardiac A&P. You will open it. All right, when you open it, it's going to lead you to a document. This is the Canvas version of the practice and review for cardiac A&P. You must complete this if you fail it before I let you take the next exam. You cannot take the next exam until you have done this. Now, this is not for a grade. It's not going to hurt you or help you, but it does keep you from taking the next one if you don't complete it. That shows us that you went in and you actually went and studied, try to figure out what you missed, right? So, for example, the questions, the first sound, a heart sound is associated with what mechanical event in the cardiac cycle. Some of these questions you might not have heard in the lecture. They're really a little bit deeper than the lecture and the basic reading. You got to go deeper into the book to find these answers. That's why it's a practice and review. So they're different numbers, guys. Some of them are like 30, some of them might be 40, but they're questions, okay? Sometimes I go over some of these before tests just to see how deeply we're learning, right? Like 17, which of the following electrolyte abnormalities associated with weakening of the myocardial muscles? Which one of these electrolyte abnormalities? You got to first know what the electrolyte is. Hypernatremia, is that potassium or is that sodium, right? You have to know that's in the reading. So that's why I'm just showing you, it takes you a little bit deeper, okay? This one happens to have 29 questions. You will do 1 through 29 on your paper and just put your answers, all right? And then you have to take a picture of it and email it to me because these are not submitted through Canvas, okay? If you did not pass, you take the practice and review for whatever unit we're on. We happen to have done cardiac A&P. You will open this up, work on it, take a picture of it, and email it to me. Don't try to upload it in Canvas. There is no upload, okay, for this. That's how you do that. Once I receive that, then I say, okay, you did it. That's good. You're eligible to take the next exam. Now, it's not due today. It's not due tomorrow. It's due before you take the next exam, okay? So if you want to turn it in the day of exam, that's on you. But don't forget to turn it in, okay? So that's how we do that. Now we're going on to the next section, which is C, pulmonary A&P. So let's look at some of the objectives for pulmonary A&P. All right. Now, objectives for pulmonary A&P. Recall the divisions and compositions of the upper airway, the lower airway, the tracheobronchial tree, and the lung parenchyma. The lung parenchyma is where the magic happens. You're going to hear me say that a lot about the magic. You've heard me say it before. It's when gas is exchanging. That's the magic, where the oxygen is being released into the tissues and the CO2 is being released into the lungs so it can blow it out. That's called gas exchange. And that happens in the little bitty air sacs called alveoli, right? And the alveoli live in the parenchyma of the lung. Okay? So you're going to have to know what all is encompassed in the upper airway. What's in the lower airway? The tracheobronchial tree. It starts with the trachea, but it breaks down into an upside down tree. You got to know the divisions of it and what's involved there. What type of tissues are in each division. Okay? Discuss the function of each division. Recall the generations of the lungs. But I don't make you guys know all the generations, just the first one or two, as far as knowing it by the generational number. You will know what it is and how it functions, but as far as, this is generation 16, you don't have to remember it like that, okay? Describe the location of the lung. Where is it located? In the surrounding organs. Describe the characteristics of the chest and the thorax. The thorax is the rib cage. Everything in the rib cage is protected. It's called the thorax. Okay. Recall bony structures of the chest. The bony structures of the chest. Let's see here. Describe goblet cells, submucosal glands, and cilia. The goblet cells, the submucosal glands, and the cilia. Those are very important structures in the lungs. Be able to tell me the difference between mucus and sputum and surfactant. Describe the purpose of the mucociliary excavator or elevator. Mucociliary elevator. So I already know that something's going up, right? That's a movement of something going up. And then the 3 types of alveolar cells and describe their functions. All right, must get a 75% to pass this exam. So just to recap on what you need to know, let's look at the syllabus. What pages should you be looking at in the syllabus? And you can look at over here, or you can go to modules. And I'll make sure I move that syllabus down. As I know the syllabus was probably not in this C one, but I know the syllabus was in this last one. But I'll move it down. So see how it says 2012 syllabus? I'm going to move it down to 210C. So the syllabus will always be in each module that we do. Boom, there it is, the syllabus in 210C. What chapters do we need to be looking at in Egan's for the syllabus, for this chapter? Okay. So here's the syllabus. We have completed A. We've completed B. Took the P's, lab and test on Tuesday the 12th. Today is Wednesday the 13th. We are starting pulmonary A&P 210C. The reading assignment is Egan's chapter 9 and 16. Egan's chapter 9 and 16 are only 2 chapters that you need to really focus on in your book. Okay. Homework for this one says homework 1, 2, and 3. I may do all 3. I may do 1. I may do something else. Remember, homework is assigned daily by me. So don't just go on and start doing stuff thinking that you got it, okay? Now, we will lecture today. We will lecture tomorrow, the 14th. But the 15th, you're off. The 15th through the 18th, you're off for Martin Luther King holiday. You will return to class on Tuesday the 19th with lecture. We'll finish out the lecture on the 19th, and then on the 20th, you take the exam. We also have a lab for that day, which is the hand washing lab. Very, very easy lab. You're going to take the test, and then we're going to go over to the lab and professionally wash our hands, and you go home, okay? Very simple. We'll have more with that before we get closer. I may have both groups come a little earlier or whatever, but if you already got time taken off, that's fine. But this is the day that you have to be here on the 20th. January 20th, 1 to 3 for my alpha group, 4 to 6 for the omega group. The checkoff is on page 37. The checkoff is on page 37. That's where I will check off and sign like I did yesterday. There is no assignment in the lab book this time. Okay, you'll notice there is no assignment for the lab book. You just come, take the test. We're going to wash our hands and we're going home, right? So this is a fairly straightforward module this time, okay? This is your chapters to read and listen to the lecture, of course, and be responsible for those for the exam. All right. That's you. I don't know why I can't mute you. I'm gonna put you in the waiting room and see if I can fix it. All right. All right, so let's get started. And then Macintosh, I had to mute you as well. Your was not muted. All right, it might even been her making that noise. Okay. All right, so let's get it. All right, first we're going to talk about the upper airway. The upper airway. This is the first part or the higher part of the respiratory tract. You have an upper and a lower, okay? Upper airway consists of the nose, the mouth, and the pharynx, okay? And the pharynx is broken down into 3 parts. So let's look at it. The nose. It's going to come. It's coming. The nose. The nose warms, humidifies, and filters the gas, right? The nose is responsible for warming, humidifying, and filtering gas. Now, when I say gas, I'm talking about oxygen and all the gases that we inhale. Oxygen is considered to be a gas. It is a gas. Not only is it oxygen, but we have argon, we have carbon dioxide, right? We have trace gases, we have nitrogen. All of that is made up in the atmosphere. Right now, as you speak, the room is a mixture of gases. You got oxygen, which is 21% of the gas in your room, where you are right now. 21% of that air or that gas is oxygen. Oxygen makes up about 21% of room air. That's why we call it room air. When somebody is not on oxygen and they're just on room air, that's room air, which is 21% oxygen. It's about 78% nitrogen that you're breathing in. All right. And we'll learn those a little more in depth as we go to pulmonary mechanics. All right. But the basic thing I want you to see is it's gas. And when that gas enters into the body, it enters in through the nose first, right? And it's going to warm, humidify, and filter the gas. What are the jobs of the nose? What's the job of the nose?
Warms, humidifies, and filters gas.
Warms, humidifies, and filters the gas. That's what the nose is supposed to do, okay? It has the external opening, is what you call the nares, right? And then we have something called nasal concha. Nasal concha. And the concha turbinates allow maximum air surface contact. So what they're saying is this. The nasal concha is this area up in here, okay? As the air goes in through the nose, it swirls around in the nasal turbinate or the nasal concha before it goes down. It swirls around like a maze. It's like a maze in your nose called concha. And as we breathe in, the gas goes in and it kind of swirls around before it goes down. The reason being is because it's trying to maximize surface contact. The longer it's touching your skin, the more it gets warm. The longer it's touching your skin, the more it gets moist. And the more it's touching the skin, the more it can filter. That's why you have hairs in your nose and all up in your concha. There's hairs there to catch foreign particles. And then it's going to swirl so it can warm up and get wet. All right? Humidifies. It's humidifying the gas because when we're breathing in now, it's very dry, right? And depending on where you are, if you're in a really humid place, it doesn't have to work as hard because it's already humid outside, right? But if you are in the tundra and it's really, really cold, what do you notice that when you're standing outside at the bus stop when you were young and it was real cold, what was your nose doing?
Running.
Reason why it's running is because it's saying, damn, it's dry. Cold air is very dry, okay? And so since it's so dry, the nose is working hard to wet it up. And so it's bringing all of the moisture to your nasal concha so it can warm up and wet up that gas. That's why your nose is running. That's why your nose is running when it's cold, all right? So that's the job of the nose, the primary job of the nose. Very, very amazing job, because if you don't have your nose, say we bypass the nose and we put a trachea in. Now when he's breathing through this trachea, he's not breathing through the mouth or the nose anymore. You have now bypassed all of the moisture and wetness and given straight dry gas straight into the lungs. That's why as a respiratory therapist, if you have a bypassed airway, that's what that means. You have bypassed the nose and the mouth and went straight to the lungs. When the airway has been bypassed, you must heat and humidify that gas. You have to. You got to put water on it and humidity. Okay? I mean, water on and heat. All right? You have to, because that's the job of the nose. And when you bypass the nose, now it's just dry, straight up dry air getting into the lungs, which will cause a problem, dehydration. Okay? All right. Let's continue on. Let's look at it. All right. So the job of the nose is to warm, humidify, and filter the gas. This is a picture of it right here, where you can see it a little bit better. See these little grooves? Those grooves are called the nasal concha. So the air comes in, goes around and around these grooves, and then goes down, okay? The nasal concha, they maximize surface contact, okay? They want it to touch the skin. The longer it touches the skin, the more wet it gets. The longer the air is touching your skin, the more moisture or heat that it gets, okay? Then it can go to the lungs, because the lungs will not take dry gas. They don't want it. They want it to be a certain humidify and a certain temperature. Somebody tell me, what temperature do you think the lungs expect the gas to be? What temperature?
Body temp?
Which is what?
98.6 Fahrenheit.
Yeah, or 37 degrees Celsius, right? So alveolar air or lung air needs to be at body temperature. That's what it wants. So that's how it gets there. How do you think it gets that way? Because the nose. Okay, the nose is what heats it up to that body temperature. All right, if the nose is not there or not doing its job, then you have to do it for it. All right, now the upper airway also contains the nose, the mouth, and the pharynx. Now this is the mouth. This is a sliced cadaver. This is a real human dead cadaver. Okay, and they laser slice their face open so you can see it. Okay. This is a real cadaver. This is his teeth. And what is this big muscle here? That's his tongue. That's his tongue. Okay. And so this is his mouth or his oral area, and this is his oral pharynx. You have a nasal and a nasal pharynx. The pharynx is behind, right? So you have the nasal or the nasal pharynx, the oral pharynx, and then you start going into the laryngopharynx, right? And so this is what I'm talking about. Air comes here, swirls around, gets hot, gets wet. Or if you're a mouth breather, it's going to swirl around your back of your oral pharynx, and it'll get a little moist and warm, but not as much as the nose does. That's why if you're a mouth breather and you wake up in the middle of the night, your mouth is extremely dry because you've been sleeping with your mouth open. Okay, it's not designed to wet and moisture or heat up the gas like the nose is. Okay, therefore we keep on going down. Now, the upper airway consists of the nose, the mouth, and the pharynx. The pharynx is the back portion, right? The back portion. So that pharynx is broken down into 3 different parts. The nasopharynx, the oral pharynx, and the laryngopharynx. Okay? The pharynx is broken down into 3 parts: the nasopharynx, the oral pharynx, and the laryngopharynx. All right. I think somebody tried to get in. Hold on, let me make sure everybody got in and was trying to get in. Okay, yeah, we got 15 people on deck now. Okay, well, still missing some people, but all right. I'm recording. All right, so let's move right on along. This is another little side picture of some things you can have. I think you might even have a worksheet with this on it. You can use that to fill out your worksheet or whatever if I assign it, but learn some of these parts. You don't have to learn every single thing, but these are some of the parts here. You got your nasal vestibule, that's just showing the nasal area, the nostril, right? The heart on the top of your roof of your mouth, that's called the hard palate. Your hard palate. You see you have soft palate back in the back there. This is his tongue, right? But some of the things you really want to look at, like that piece of meat that's hanging in the back of your throat, the little piece of the meat. When you open up your mouth and you look in the mirror and you see that little piece of meat hanging in the back of your throat, somebody tell me what that's called. The uvula. That's your uvula. That little piece of meat is your uvula. Okay. Then you have your tonsil, right? And this will be your oral pharynx, because the oral pharynx is the area behind the mouth. So behind the mouth is the oral pharynx. Behind the nose is the nasal pharynx. Okay. And behind the larynx is the laryngopharynx. All right, the laryngopharynx. Now, what about these right here? Somebody tell me what you think this is. What are these right here? This little part right here.
The vocal fold.
Vocal cords. So that's your vocal cords. Those are your vocal cords. That's the opening that goes into your lower airway. Notice how your trachea is in front and your esophagus is in the back. So if I was using my directional terms, I would say the trachea is what to the esophagus?
Anterior.
Anterior. Excellent. The trachea is anterior to the esophagus, or the esophagus is posterior to the trachea. Okay, it's behind it. All right, this is where the food goes, and this is where the air goes. Okay, your vocal cords are over your trachea because the air comes from your lungs, goes through the vocal cords, and comes out your mouth as speech. That's how you're able to talk. Your book has good pictures of the areas we're talking about now, some real pictures and some animation pictures. But you make sure you're reading and highlighting in your book as well. Okay. Now, we're going to talk about this cricoid cartilage here really soon, in a minute. But this is the upper airway. The upper airway is really up through here because this stuff down here starts to get into the lower airway. What about this olfactory epithelium, this skin called olfactory epithelium? What do you think that is? What kind of skin is that?
It helps you smell.
Smell. That's the skin that allows you to smell what you just smelled. That smell goes to that skin and tells your brain, oh, that's a fart I smell. Or, oh, that's pizza. Or that's a burger. It goes to your olfactory epithelium. And it says, that's what this is, right? And tells the brain that's what it is. Okay? It's very intricate and very amazing what the upper airway and the airway period is responsible for. All right, this is some of the upper airway. All right, now let's talk about the lower airway. This is still the same cadaver or maybe another one. These are his muscles that have been freeze dried or however they preserve them. But these are muscles, right? And this is his neck area. This is his thyroid cartilage, right? So when you put your finger on your throat, the Adam's apple is the thyroid cartilage. The thyroid cartilage is known as the Adam's apple. Okay, yes, women and men have thyroid cartilage. Men is a little more pronounced than women, but you still got one. Okay, it protects your thyroid. All right. Then you have your parathyroid glands. Then your trachea. I want you to see this. This is your trachea. This is where we're starting to get to business. Okay. We're going to start to get to business. And you can barely see it, but there's tracheal cartilages or rings there. Okay. And you'll see a better picture of it when we get to the trachea. But the lower airway, what does it start? It starts with the larynx. Okay. So after we did our nose, mouth, and pharynx, which the pharynx is oropharynx, nasopharynx, and laryngopharynx, right? It's broken down into three parts. After the pharynx, we now have the larynx. That starts the lower airway. So if you think about larynx, lower, LL, right? If they say, where does the lower airway start? It starts with the larynx. Starts with the larynx. All right. It extends from C3 to C6 vertebrae. Somebody tell me what the C stands for.
Cervical spine.
Cervical vertebrae. So in our vertebrae, if this is our vertebrae, this is Mr. Johnson's vertebrae. All of this, right? The vertebrae, your backbone. Okay. It is made up of three or four sections. You have cervical, which is neck. You have thoracic, which is the back, mid-back. You have lumbar, which is the lower back. And you have sacral. Okay. Cervical, lumbar, cervical, thoracic, lumbar, sacral. Okay. Don't take for granted this sacral bone. You break that bone, you in excruciating pain. Okay. Don't think it's little, don't cause nothing. That's your butt bone. Okay. That bone right before your anus. That's your butt bone. Your sacral. Okay. And so what they're trying to tell you is where it's located. Where is the larynx located? They're saying it's about C3 to C6. So you count these. 1, 2, 3, 4, 5, 6. So about C3 to C6 is where your lower airway starts on the front. Okay, they're just trying to give you a landmark. Okay, giving you a landmark. All right. Now, the lower airway is made up of unpaired cartilage. Okay, unpaired cartilage and paired cartilage. It's not bone. In the front, this is not bone, this is cartilage. Like, feel your ear. That's cartilage. Okay, that hard structure in your ear, mainly the one that's closest to your head, the part that's closest to your head, that cartilage, that's cartilage, right? Your nose is got cartilage in it. That's what it's made of, okay? It's not bone. Now, the unpaired cartilage will be your epiglottis, your thyroid, and your cricoid. The unpaired cartilage of the larynx is the epiglottis, the thyroid, and the cricoid. And I'm going to show you these. And then the paired cartilage is the arytenoid, the corniculate, and the cuneiform. The paired cartilage is the arytenoid, corniculate, and cuneiform. What you're going to talk about the most will be that unpaired cartilage, which is the epiglottis, the thyroid, and the cricoid. We're going to talk about that a lot.
Mr. McCarthy, can you say the unpaired cartilage one more time just so I can hear?
Unpaired cartilage is the epiglottis, the thyroid, and cricoid. Can y'all see my screen? Okay. Epiglottis, thyroid, and cricoid. The special thing about the epiglottis, I want you to know what that epiglottis is for. Can somebody tell me what the epiglottis is for from your previous education? What is the epiglottis?
It covers the larynx.
Yeah, it covers
like the swallowing.
Yes, it's a little piece of meat that covers the airway when you swallow.
It prevents food from entering the trachea.
Exactly. This right here. This little guy right here, this is the epiglottis. Because look what it does. When you eat some food, the food's supposed to go which way? Where's the esophagus on this guy? Anterior, or is it anterior or posterior? The epiglottis.
Posterior.
The esophagus is the
posterior.
Esophagus. Yes, posterior. This is anterior, which is the trachea, airway. Posterior back here is the esophagus. See how skinny it is? It only opens up when you eat and swallow. It's called peristalsis or peristalsis, something like that. It squeezes the food like cartoons. When you see water going through a water hose on cartoons, it's like the bubble is moving. That's what happens to your esophagus. Okay, it pushes it down in bubbles, in sections. Okay, and so does what stop working? Swallowing mechanism. Something in your brain. He couldn't get it. Yep. Your brain, all that's some different signals from your brain. Yeah, different nervous systems and different. That's an autonomic issue, like breathing and heartbeat. You can't make it start or stop. Just like swallowing, you can't make yourself stop being able to or swallowing. Right? It's just a connection. I don't know exactly what it is, but there's a connection in the brain. But so when I eat pizza and I swallow, this epiglottis will close over this right here. So this right here will do this. Boom. Right? This is it right here. Epiglottis, it will boom, close. So the food doesn't get in my air pipe or my trachea. Sometimes it does. And when food gets in your trachea, you notice it. Right? You cough violently. The body goes into a violent cough, almost passing out, because it does not want anything in the lungs but air. Okay, so that's its way of protecting itself, right? The gag reflex. And somebody sticks something down your throat and you gag, that's because you're getting down there close to that airway, and they don't want nothing in the airway but air. When you do, you gag. Okay, and so people do that to make themselves vomit if they're sick or whatever, because they know they're going to gag. It's going to force things back that way. All right. So you have to be, that's called a gag reflex. All right. That's something we look for as respiratory therapists when we're considering taking the tube out of somebody's throat. Does he have a gag reflex? Because if he don't, he can't protect his own airway. And the tube that I have in is protecting his airway because the tube has a balloon on it. See that balloon there? This balloon, when I stick this in your airway, I fill it up, and this will go through, and that seals the airway off. So secretions that's coming around your mouth, they don't leak into your lungs. Food or anything like that that you done ate does not get into the lungs. So I'm protecting your airway, right? But because if I stick my catheter or something down your throat and you don't do nothing, that means you don't have a cough gag reflex. You're not ready to be extubated. All right. Only when you start coughing and gagging, that's okay, good. He got a good strong cough. He can protect his airway. Now we can consider removing the tube. All right. So all these are things you're going to be considering before you move the tube, because guess who takes the tube out and guess who puts the tube in? Respiratory, not the nurse. Okay. All right. Okay, so we got the epiglottis. That is for protection of the airway, not to be confused with the glottis. Epiglottis and glottis are two different things. Epiglottis and the glottis are two different things. The epiglottis is a piece of unpaired cartilage that protects the airway upon eating. Okay, the glottis is a hole. The hole that is in between the vocal cords. That hole, which leads into the lower airway, is called the glottis. Yeah, just Glottis. All right. So I'll show it to you right quick. We're going to take a break. Just a quick picture. The glottis. So say this is the vocal cords, right? If these are the vocal cords, then this hole right here is the glottis. The hole in between the vocal cords is the glottis. Okay. If they ask you, what is the structure in which you enter from the upper into the lower airway, you're going to say, oh, that's the glottis. If I was on the Magic School Bus and we're traveling through the body, right? Anybody remember that when you were younger? If I was traveling on a Magic School Bus through the body, I would have to go through the vocal cords, through that hole, which is called the glottis, to get to the lower airway. Okay? All right, so it's 50 after. Let's take a break. Come back around 2 o'clock. Let's take a break to about 2 o'clock. I'm going to pause the recording, and we're going to come back. I'm going to go back to the lesson plan so you can write whatever you might have thought you needed to write, because the PowerPoint pretty much comes straight from the lesson plan. But I like to go back so people can, oh, I didn't see that or whatever, and they write what they like to write, okay? So come back at 2 o'clock. We will continue on with the lower airway. Okay, guys, we're back from break, and we are still talking about the lower airway. So I'm gonna show you this photo here, and then I'll go back to the lesson plan notes and make sure there's nothing that you're missing. But this is a figure of a lower airway. Okay, we're starting at the lower airway. You have your thyroid membrane. You have this big part here is your actual thyroid cartilage. Looks like a butterfly, right? This is the thyroid cartilage, also known as the Adam's apple. Okay. Then you have some important cartilages or cartilage, I guess, to talk about. This is called the cricoid cartilage. The cricoid, make sure you write this down. The cricoid cartilage is the only complete ring of the trachea. The cricoid cartilage is the only complete ring of the trachea. The rest of the tracheal cartilage are C-shaped, like little staples. They're C-shaped rings, okay? If I showed you this one, because it's kind of hard to show, I can show it better in the book when we get to one of those pages. But if I was looking at this, this is half of the airway, okay? We had this is the Adam's apple, right? Or the cricoid, I mean, not the cricoid, but the thyroid cartilage. And then you have your thyroid glands here. And then you have, starting with your trachea, right? The trachea is starting to come down this way, okay? And you see these little rings, these little boom, boom, boom. These are little C-shaped rings, right? And the only job they have is to keep it open, right? They keep the trachea from collapsing because the trachea is just tissue, right? It's not a bone. And so it has these little C-shaped rings on it to hold it open, okay? It just gives it's like a backbone almost. It gives us stability, keeps the trachea from collapsing, all right? If you didn't have these little C-shaped rings, the trachea would just collapse like a, like a balloon, just an open up balloon and just collapse, right? So it has to have these little C-shaped rings for stability. But all of them are just C-shaped except one, and that's the cricoid cartilage. The cricoid cartilage is the only complete ring of the trachea. Okay? This is kind of bulky. You have your thyroid cartilage, right? This is that thyroid tissue up in here. This is the thyroid cartilage, also known as the Adam's apple, right? Then you have the actual thyroid glands there. And then you have, this is starting the trachea, which is going to start going down into the lungs. Okay, it's going to bifurcate left and right and go on down into the, and call it the Tracheobronchial tree. All right, upside down tree. This is the root here. The tree is going to spread out going down. Okay, so there's only one complete ring, and it's usually at the top, and that's called the cricoid cartilage. So the only complete ring of the trachea is called the what? Cricoid cartilage.
Cricoid cartilage.
Good. That's very important. Okay. We use that for a landmark. We also use that in aiding intubation. Okay. Because the airway is anterior. Some patients are really anterior. Okay. And so when I'm putting the tube down your throat to breathe for you, I got to be able to see the vocal cords. Okay, that's what I'm looking for. So when I put the blade into your mouth, right? I put the blade into the patient's mouth. There's a blade we use that moves the tongue out the way, and it lifts this part of the skin up, the palate up with the blade. And then when I'm looking, it has a light on the end of the blade. And when I'm looking for that vocal cords, right? And sometimes some patients are so anterior, right? It's like they are really a big neck, and so their neck kind of come out this way. So it's hard to see up in there, right? And so what we do is tell them, hey, give me some cricoid pressure. And they find the cricoid and push down. And when they do that, they push the airway into my view, and then I can pop it with the tube, okay? So the cricoid cartilage serves a lot of purposes. But you need to know that the main thing about it is that it's the only complete ring of the trachea. Okay, so as that trachea continues to go down, it looks like this. We have the trachea starting here, right? Cricoid cartilage at the top, and the rest of these are all C-shaped rings. These are all little C-shaped rings. They go all the way down. Look at that. This is the trachea. And it bifurcates. The trachea bifurcates the left and right main stem bronchi, right? Or bronchus. Main stem bronchus. So this is the trachea. Then this is left and right main stem bronchus, right? This place where it bifurcates is called the carina. Carina. Make sure you write that down. So we're talking about this airway. You have the trachea, goes all the way down and it stops right here and it bifurcates to the left and right main stem bronchus. Okay? All of these little rings that you see on here are all little C-shaped cartilages. See them? And see how it starts to bifurcate again, and then it bifurcates again. It's like a tree. It's an upside down tree, right? It's what we call the Tracheobronchial Tree. Starts up here with the trachea, right? Trachea comes all the way down to here, made up of C-shaped rings. You're going to learn how many rings are there. You're going to learn how long the trachea is. And the only complete ring of the trachea is the cricoid cartilage, right? Which is up here, cricoid cartilage. And then when it comes all the way down, it stops and it bifurcates. Bifurcate means it turns into two, right? Branches off to the patient's left and right main stem bronchus. Okay. And then you're going to learn, then it goes into bronchi, segmental bronchi, bronchioles, terminal bronchioles, and then respiratory bronchioles. And that's where the magic happens. Way down at the end. Okay. Can't even see it with your eyes. All right. Now remember, I told you how many red blood cells do we have? Million red blood cells, right? Guess how many alveoli we have down in the parenchyma of the lungs? How many alveoli do you think we have?
400 million?
300 to 600 million. 300 to 600 million alveoli, those little air sacs where the magic happens. There's 300 to 600 million of those, okay? So that just kind of gives you a scale of what we're talking about. All right, let's keep going. This photo on the right is an actual gentleman's drawing who was a physician back in the 1800s, and this is something he drew by pencil. So it's not exactly totally anatomically correct, but it's very close. It was very close. So I just threw that on there. Now let's look at this there is one bone in the lower airway, and that's called the hyoid bone. This little hyoid bone, if somebody gets strangled, this breaks. When that breaks, it kills you, okay? So when you get hung or somebody strangles a woman or a man to death, they usually break the hyoid bone. When that hyoid bone is broke, it kills you because that airway collapses. That bone is keeping the airway open, right? It's like the lid, like the rim of a cup, right? This thing of this bone, if this was a bone here, this would be the hyoid bone, right? Going around the airway. But if that bone breaks, then this smashes, right? And there's no way to breathe if there's no stability there, okay? Totally cut off, all right? So that's called the hyoid bone, right here. Okay, so you have your hyoid bone, then you have your Adam's apple, which is the thyroid cartilage. And then you have the trachea. And the trachea has C-shaped rings. See this ring here? That's a C-shaped ring. This is a C-shaped ring. This is a C-shaped ring. And they just like staples. They go all the way down the trachea, except for this one. This one goes all the way around. And that's called the cricoid cartilage. So I said it 100 times, so you best believe it's a test question. Somebody will miss it. All right. This is a computer animated actual tracheobronchial tree. This one here is I forgot what they call it, but this is some type of computer image here. And this is also a computer image, but this is more the real thing. This one is just kind of showing you where there's a blockage, okay, in this patient. So that's how the doctor will find out where the blockage is, okay, some kind of stenosis in your tracheobronchial tree. But over here, this is about how it looks, like an upside down tree. This is your trachea, and it comes all the way down and bifurcates into the, this will be the left over here, left and right. Remember, it's the patient's left and right. So left and right, main stem, bronchus, right? And then they break into bronchi, then bronchioles and terminal bronchioles, and the little sacs will be all the way at the ends of these, okay? But that's what a trachea looks like. The tracheobronchial tree, that's what it looks like, okay? Amazing. All right, it's amazing. So let's look at the notes, see if we missed anything. Lesson plan, boom. All right, so we talked about that. Yeah, so the mouth, the upper airway was the nose, the mouth, and the pharynx. All right, the nose has those nasal turbinates or nasal conchi that allow for maximum surface contact. Posterior nose is ciliated, pseudostratified columnar epithelium. That's just the type of skin it is, the cells, whose purpose is to filter, humidify, and warm the gas. So people who have hairs all in their nose, you say, "Oh, you got hair in your nose." Well, that's what it's for. It's there to filter gas, because those particles and different dust mites and all kind of stuff that you breathe in, it gets trapped in your nose hairs. And then what the nose hairs don't catch, the mucus catches. Okay, you're gonna learn about the mucociliary escalator. It's got a process and a job to do. The mouth, also known as the oral cavity, it's lined with stratified squamous cells. All right. Then the pharynx extends from the base of the skull to esophagus, about 5 inches. The pharynx is about 5 inches, and it's broken down into 3 parts. The pharynx is broken down into 3 parts, and we said that is the nasal pharynx, Laryngopharynx, yes. So the nasal pharynx, which is behind the nose, right? And they're saying that's the conchi to the uvula, right? That conchi back to the uvula is considered the nasal pharynx. It's lined with pseudo-stratified ciliated columnar epithelium cells. And the purpose for those is to gas conduction to the airways, filters and houses the adenoids. So the nasal pharynx is for gas conduction and filters and houses the adenoids. You ever heard somebody say, I gotta get my tonsils removed and my adenoids? Just the defenses. Tonsils and adenoids are there for bacteria. They catch bacteria and keep it from getting in the body. It's kind of like immune system in your throat, and that's your tonsils and your adenoids. All right. Now, I want you to write a side note. All of the airways of the tracheobronchial tree, all of the airways, all of the different structures are for gas conduction, except for the respiratory bronchioles. Okay? All of the structures of the airway, from the nose all the way down, are for gas conduction. When I say conduction, what do I mean by conduction? What do you think conducting means? When you think of a conductor, what do you think that is? Gas conduction. When you think of gas conduction, what do you think about? Controlling it, or its direction, right? When you ride a train, the conductor says all aboard, right? The conductor of the train is a person who conducts the train, moves the traffic, or moves the train to its destination, right? So when gas enters into the body, right, it gets into the nose, the mouth, the trachea. All these places are for conduction. And guess what the destination is? The land of the parenchyma, okay? Because where the parenchyma is what happens, what I call it? Huh? The magic. So the oxygen gets on board. All aboard the tracheobronchial train, okay? Your nose, your trachea, your left and right main stem bronchus, your bronchi, your terminal bronchi, your bronchioles, your bronchi, segmental bronchi, then your bronchioles, terminal bronchioles, all are considered conducting zones. All they do is move gas. There's no magic happening in the conduction zone, okay? No magic is happening in the conduction zone. All it's doing is conducting. It's trying to get the gas from out here into my parenchyma, okay? Only when it gets to my parenchyma can magic happen and gas exchange happens. That's how the oxygen gets to your tissues, because it first gets all the way down to your parenchyma, which is your alveoli, your air sacs. When it gets there, it will transfer or exchange gas with the capillaries that are around it and give you your oxygen and get rid of your CO2. All right.
Mr. McCarthy, what was the exception?
I'm about to write it. It's your respiratory bronchioles. All right, so okay. Trachea. This is my left bronchus, right bronchus. And then it bifurcates down again to your bronchi. And then even further, bronchioles, and then even further, terminal. Terminal bronchioles. What happens at the terminal? When you ride the bus or the train, you get to the terminal, what you got to do? Get off, right? So all of this is considered to be conduction zone. All of that is the conducting zone. From your trachea all the way down to your terminal bronchioles is simply for conduction. It's just trying to move gas to get it to the parenchyma, right? And then after it gets to the parenchyma, which we call the land of the parenchyma, which is the magic, right? That's where the magic now starts to happen. There is no gas exchange before this. Before this, it's just a waste of time. All it's really doing is just moving the gas, okay? It's just moving the gas. Then it gets to a zone. It gets to the magic. So let's just say, there we go. After that, it goes into what's called the respiratory bronchioles, also known as the land of the parenchyma, which I need to look at it because I don't forgot how to spell that. Let me find parenchyma right quick. All right, P-A-R, somebody tell me that's P-A-R E-N-C-H land of the parenchyma, after this area right here. Okay, so this is conducting zone, and this down here is the magic. Gas exchange. Everything below that. So the oxygen and the gas that you inhale, let me take this screen share off. The oxygen and everything that we inhale enters in through here, right? And all of this is simply conducting the gas to get to the terminal, right? When it gets on the terminal, it has to get off. It steps off into the land of the what? Parenchyma, which is also known as the respiratory bronchioles. This is where we start to find the alveoli. The little air sacs are not on none of this. The air sacs are not on any of the other airway parts. It's only in the respiratory bronchioles that we start to see alveolar clusters start to form. They start out in little clusters, okay? And each cluster has about 15 to 20 alveoli. And we have a total of 300 to 600 million alveoli, right? And these alveoli are these little air sacs. They look like this, right? 300 to 600 million. $300 to 600 million alveoli. These right here. This is where the gas exchanges. This is where the magic happens. Okay? Inside of this, we have oxygen. Oxygen is inside. It comes in from when you're breathing it. It finally makes it down to the alveoli, which comes in oxygen. Now, something is riding the side of that alveoli, and it's called the capillaries, which are little vessels. Remember we said the capillaries were in between what and what? Capillaries are in between what and what? When we talked about it, we said you have this and you have this and you have capillaries in between. What are these vessels I'm talking about?
Arteries and veins.
There you go. Arteries and veins. And in between arteries and veins, you have capillaries. Well, think of this. These alveoli have capillaries wrapped around them. Think of a bunch of grapes. Okay? You got a bunch of grapes in your head? You got them in your head? Think of a bunch of grapes. You're holding a bunch of grapes, a little bunch or a bundle or whatever you call them of grapes. Those are, each little grape is an alveoli. Imagine if you put those bunch of grapes in some fishnet stockings. The stocking, the little fishnets are the capillaries. Okay? The capillaries wrap around them, all over them. Okay? And that's where gas comes in and out of the alveoli. The alveoli will give oxygen to the capillary, right? And the capillary will, put an arrow like that. The alveoli will give oxygen to the capillary, and the capillary will give what to the alveoli? What would it give it? If the alveoli is going to give good good, strong oxygen to the capillary? Carbon dioxide. So then the capillary will give up the used blood or the used gas, which is CO2. That's the gas exchange. You give me oxygen, I'll give you CO2. You give me oxygen, I'll give you CO2. You give me oxygen, I give you CO2. That's the gas exchange. That's the magic. Okay? Now, so this is what happens with that. Another way to look at it is this. All right. Let's say this is my alveoli. You have, what color is deoxygenated blood? Blue. So you have on this side riding the side of the capillary, you have your deoxygenated blood, right? All right. This deoxygenated blood is putting what into the alveoli?
Oxygen? No, carbon dioxide.
Carbon dioxide is used up, right? After the body used up the oxygen, carbon dioxide is the byproduct of metabolism, okay? And so the used up blood now has gas in it, which is not oxygen, but carbon dioxide. So this is giving CO2 to the alveoli, right? And then as you take your breath, of course, oxygen, which comes in, right? Oxygen that you breathe is then pushed into the capillary, turning the capillary what way? Red, because it's now oxygenated. And this blood now, this is O2 going in, right? Oxygen goes into the capillary. So the capillary gives CO2 and picks up oxygen. Now it's returning to the heart via the what? Blood comes back to the heart via the what? From the lungs? Pulmonary veins. So this dumps into the pulmonary veins. This capillary will dump into the pulmonary vein and return to the heart so that you can pump it to the body. Okay? It came from the pulmonary artery, right? The pulmonary artery takes blood to the lungs, okay? The alveoli, guys, is the lungs, right? That's what we're talking about. The alveoli is considered the lungs. So when it comes from the pulmonary artery, it goes to the lungs. The lungs then get smaller, though the pulmonary artery and all those arteries get smaller and turn into capillaries, which is deoxygenated, full of CO2. When it gets into the lungs, it pushes the CO2 into the alveoli, and the alveoli will push oxygen into the capillary. And then it's full of oxygen and returns, this blood will return to the heart via the pulmonary veins and dump into the left atrium, then into the ventricle, left ventricle, and then to the aorta, and then to the body, and to do it all over again. When that oxygenated blood gets to the body, it's going to get used up during metabolism, right? Your feet, your arms, everything uses it. Then it returns back to the heart, deoxygenated, right? Full of CO2, because CO2 is the byproduct of metabolism. When we metabolize, we make a waste product called carbon dioxide, okay? And so that carbon dioxide rich blood returns to the lungs, right? It's returning to the lungs from the pulmonary vein, right? And it pushes that used up CO2 into the alveoli. And at the same time, the alveoli is pushing that oxygen that you just inhaled from the sky into the capillary. It's doing this, shoo, 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 with every breath and every beat of your heart. Okay, that's why heart and pulmonary are so important for the respiratory therapist, so that you can understand how gas exchanges. Now this is happening in the land of the what? Parenchyma. In the parenchyma of the lung, not at the trachea, not in the left or right main stem bronchus, not in the bronchi, not in the terminal bronchi, but the respiratory bronchioles. That's where it starts. Okay? All right, so let's look at it with our notes. Now we're going to see this a little bit more. I don't expect you to know all about the alveolar from this, but this is what you're about to get into. Okay? This is what we are going to get into. I just need you to see as we go the process. Okay? Any questions on that process? Any questions on that process? Alveoli is located when we see the respiratory bronchioles. That's where the alveoli start to become noticeable, right? That's where you'll see the alveoli start to form. Those alveoli are the air sacs. When you take a breath in, they fill up with air. They fill up with oxygen, right? During that inspiration, the capillaries dump CO2 into the alveoli, and the alveoli pushes oxygen back into the capillary. It's an exchange. You give me O2, you can have the CO2, right? Every beat of your heart, every breath you take, this is happening, okay? That's the magic that I'm talking about. You okay, Brittany? Okay. All right. Let's keep moving. All right, then we talked about the lower airway. And we said the lower airway, all right, has functions. What are the functions of the lower airway? Number one is to conduct gas. It's also just what? Conducting gas. There is no gas exchange in the larynx, okay? It's just there to conduct gas. It protects the lower airway. It's there to help with speech and cough. The larynx functions as a conductor of gas. It protects the lower airway. It helps with cough, and it helps with speech. And they said it extends from C3 to C6, like we said in the PowerPoint. All right. Okay. It has those unpaired cartilage and paired cartilage. We said the unpaired cartilage is the epiglottis, which covers the superior larynx opening on swallowing to prevent food from getting in the trachea. Yeah. All right. It also has the thyroid cartilage, which is also known as the Adam's apple. And the cricoid cartilage. We said the cricoid cartilage is the only what?
Complete ring.
Only complete ring of the trachea is the cricoid. It's a whole ring. The rest of them are just little C-shaped rings. All right. Then we have paired cartilage. The larynx also has paired cartilage. We're still talking about the larynx now. We said the larynx is the first part of the lower airway. We talked about the larynx functions. We talked about where it is. And it has unpaired and paired cartilage. The paired cartilage is arachnoid. The arachnoid cartilage allows for vocal cord movement. That's what allows the vocal cords to move. Okay. The corniculate supports the walls of the larynx. And the cuneiform or cuneiform cartilage connects the epiglottis to the arachnoid cartilage. Now, these right here, this 1, 2, and 3, I'm not expecting you to know that on the test. It's not going to ask you about which one connects the epiglottis to all of that. You don't have to memorize this one like that. Okay, it's just good information because it is true, but this part is not tested. This little part right is that's not tested. Okay, that starts the lower airway. Okay, so let's look at it again. Upper airway, nose, mouth, and pharynx, which the pharynx is three parts. You have the nasal pharynx, oral pharynx, and laryngopharynx. Right? Now let's look at this laryngopharynx because I want you to understand this last part right here. It's lined with the stratified squamous epithelium. The function of it is to gas and what? Food conduction. Oh, the laryngopharynx, because we're still talking about the what? Upper airway now. I went back to the review. Upper airway, when we talk about the laryngopharynx, it also not only moves gas, but it also helps you move food, right? Food conduction. Which way is the food trying to go? To the what? The stomach via the esophagus, right? So the laryngopharynx has to move that food to the esophagus, right? So it's a conductor of food. That means it's moving the food or helps with the movement of the food and of gas, okay? The larynx divides the upper and lower airway at the vocal cords. So the airway, the upper airway stops where the vocal cords are, and the lower airway starts at the vocal cords, right? The thing that separates the upper and lower airway is the vocal cords. But the hole in the vocal cords is what? Huh? The glottis. The glottis. The glottis is the hole of the trachea, okay? Not, you know, so don't get it confused. The glottis is the hole of the trachea. Like I showed you just a minute ago. I mean, not the trachea, but the vocal cords. These are my vocal cords. Right? These are my vocal cords. Then this hole here is the glottis. That's the hole. So be careful when you're reading the questions, because if they say what structure separates the upper and lower airway, that's the vocal cords. But if they say the hole at which you enter into the lower airway is through the glottis. Okay.
So is the difference between the glottis and the epiglottis that the glottis is just always there, and then the epiglottis keeps the food from entering the lungs?
Yeah, the epiglottis is an actual piece of cartilage. Epiglottis is that little piece of cartilage that closes over the trachea when you swallow. Okay. The glottis is simply a hole. The glottis is just a hole in between the vocal cords.
So the epiglottis moves?
Yes, it moves every time you swallow.
Okay, okay.
When you swallow, see, the epiglottis just kind of sits like that, like this diaphragm here. This is the epiglottis right here. When you're not doing anything, it's just kind of sitting there. But when if this guy was to swallow, this would fold down and close over the trachea. And it will stay closed until the food passes through the esophagus, and then it'll open back up. Okay? That's his only job, is to protect the airway when swallowing.
Okay, thank you.
Okay? All right. So then we got into the lower airway, the larynx. We said that we talked about what the larynx is for. His job is to conduct gas, protect the lower airway, for cough, and for speech. It's made of unpaired cartilage, and that unpaired cartilage in the protection is the epiglottis. It covers the superior larynx when swallowing to keep food from getting in the airway. Okay. Then the thyroid cartilage is considered the Adam's apple. The Adam's apple. Then you have the cricoid cartilage, which is the only complete ring of the whole trachea. There's only one complete ring, and that is the cricoid cartilage. All right? Then it talked about the paired cartilage that's there, and that's the arytenoid, corniculate, and cuneiform. All right, so quick questions. I'm going to ask some questions before we go on to the next part. I'm going to call your name and I'm going to ask you a question. All right, Christian. Christian. Hold up. There we go. All right, Christian. What is the structure that you see when you open your mouth and that little piece of meat hanging in the back of your throat? Christian, what is that structure called?
Hold on. I don't remember. It is. Hold on. Is it the uvula?
Uvula. Excellent. Excellent.
Okay.
That's the uvula. All right. All right. What about this here? Let's see here. Talicia. What is the purpose of the nasal concha? The nasal concha in the upper airway. What is the purpose of that, Talicia?
The purpose of the nasal concha allows maximum air surface contact.
Good. Allows maximum air surface contact. And the more surface contact and the more air surface contact, Cassidy, does what? The more time that the air is contacting the skin, what's happening to that air?
It's getting warm and wet.
Good. Warm and wet. So that's excellent. That's something to help you remember. WW, right? Warm and wet. Get your mind out the gutter. All right. So I'm looking for my something. Look, this is what I found in my work bag. All right, so know who's been missing. All right, Kelsey. What is the hole at which you pass through to get from the upper airway to the lower airway? There's a hole there. What's that hole called?
Glottis.
The glottis. Good. All right. Brittany. Brittany, what what is the structure found in the lower airway that's responsible for speech? The vocal cords. The vocal cords. All right. Lori, what structure separates the upper airway from the lower airway? The vocal cords. The vocal cords. All right. And let's see. Heather. Okay, there we go. What cartilage is considered to be the Adam's apple? Thyroid cartilage. Good. All right. Okay. So let's move on. Now we're going to talk about the tracheobronchial tree. We'll get started on this and then we will take another break. All right. So we showed this one already. This one here, guys, is talking about we're talking about the tracheobronchial tree now as we go on down. This photo here or this diagram is simply showing you the layers of the tracheobronchial tree as far as what type of muscle or what type of skin do we find? What type of cells do we find? Notice this right here. This is what I showed you on the board. From here to down here is just the what zone? Conducting zone. And from here, down here is the parenchyma, or also known as the respiratory bronchioles, right? The parenchyma, or the magic gland, right? Gas does not start exchanging until here. All of this is just conducting. It's just moving gas to where it's trying to go. The gas has a destination. It wants to go to the land of the parenchyma. It gets on the bus and it goes until it gets there. It travels all the way to the terminal. The terminal bronchioles are the last stop of the conducting zone, okay? Once it steps off of the bus at the terminal bronchioles, it steps into the land of the parenchyma, okay? And that's where you find the respiratory bronchioles and the alveoli. These little alveoli, these are the air sacs here, okay? Like grapes, okay? Look like grapes. And they're just showing you the epithelial cells go all the way from the top to the bottom. Goblet cells can be found all the way to about this level, right? Clara cells can be found from up here down to this level. Ciliated glands. You don't have to remember all this. I'm just kind of showing you some of the fibers and stuff that you find there. Now look at this last one. Elastic fibers can be found from the top all the way through, because you're going to learn that the lungs are elastic. They're like a rubber band. When you inhale, your diaphragm drops and your lungs swell open. But when you exhale, you just let go and they automatically go back, because the lungs have what's called elasticity. All right. The lungs have what's called elasticity. Now, some people's elasticity is stronger than others. And there's some disease processes in which the elasticity is gone. Okay. And you're going to learn that as we continue on with the diseases. Okay. Now, this is a quick note of the alveoli that I showed you on the board. This will show you even better. Remember I told you it looks like grapes with fishnet stockings, right? So if you put those, these are the capillaries, right? These are the capillaries. So notice you have oxygenated blood and you have deoxygenated blood. They happen at the alveoli. That's where it becomes the change. Oxygenated blood becomes deoxygenated, or deoxygenated blood can only become oxygenated when it passes by the alveoli, because that's where the oxygen is located, okay? Oxygen is not throughout the body or in your chest cavity. It's only inside those little bitty alveoli. So notice this one down here. This is showing you that the blood is coming in to the lungs, right? Blood returns to the lungs from the pulmonary artery, and it's blue because it's deoxygenated. This is an alveoli right here, right? So what they're showing you is, as this deoxygenated blood goes by the alveoli, it pushes CO2 into the alveoli and picks up what? Oxygen. So that gas exchange happens as the blood passes over these little capillaries right here, pass over or pass by the alveoli. The CO2 leaves the blood and oxygen enters the blood. Now notice, blood coming out of the lungs, which is going back to the heart, is fully oxygenated, right? It's going to return to the heart via the pulmonary veins, dump into the left atria, then the left ventricle, then the aorta, and then back to the body. And after that, it's going to come back this way and do it all over again. Every beat of your heart is doing that. It's a closed system. Choo, choo. Boom, 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 boom. The blood is going through the body, back, through the body and back. Every single beat of your heart. This is another example here. Same thing, just different. Okay, different picture. Notice you have deoxygenated blood coming back to the lungs, because the alveoli is in the lungs. So we consider this the lungs, okay? Deoxygenated blood is coming back to the lungs. After it left the pulmonary artery, it turned into a capillary when it got down to the alveolar level. It's pushing out what? CO2. That used up CO2 is leaving the deoxygenated blood, and oxygen is going in. See, CO2 coming out, oxygen going in. So by the time it gets on this side, it is now fully oxygenated. and returning to the heart so the heart can push it to the body. See that? This one here is a microscopic picture of an alveoli, like a cross section. If I'm looking down on the alveoli, this is the capillary that's riding right beside the alveoli, right? And you have gas exchange between the two. Now, this is kind of showing you a little bit more. This is showing you the type of cells in the alveoli, which we'll talk about in a moment. Okay, so let me go back to the lesson plan before we go too far. Now, let's take a break. Let's just say it's 3, come back at 3:10. Let's take a break to 3:10, and we're going to talk about the tracheobronchial tree. Remember I told you about generations. You don't have to know all the generations, but you do it. This is a lot of information that you must know right here. We'll talk about how long the trachea is, how wide it is, all those things coming up, okay? So come back at 3:10, and we will continue on with the tracheobronchial tree. Okay, guys, I'm going to get back on it. All right, so what I'm going to do now is I'm going to put this link in the chat because I can't, it's a little quick video about the respiratory, just kind of see what we've been talking about in an animation. I put the link in the chat that you can watch for those who are going to be watching this later. You can watch it later because I can't record it because it won't let me, because of copyright infringement. All right, so at this point, if you are watching this from later and you're watching the recording, look in your chat now, and you should see the link. If you can't find the link, you just have to keep scrolling through the chat box. It might not be right there when you're looking at right now. I don't know how it works later, but look for it. It's going to be a YouTube link that you can click on and watch it later for your own time. Okay, so I'm putting it in there now. There it is right there. And now we're going to play this. It's like 3 or 4 minutes. And so you can kind of see what I'm talking about with the inhalation and what's happening with the alveoli as the blood or the gas travels down the conducting zone down to the land of the parenchyma and how that gas exchange happens. Okay, so here it is. We're going to watch this and then we're going to continue on with the notes. Let me stop the recording. I want to stop the recording for this video, then I'll resume the recording after the video. Okay, talking about very, very excellent video. So that video is here over here, the link. If you want to watch it again, or you want, if you're watching this now as a recording, you can watch it on your own time. All right, but we're now recording again, and let's keep on going. We've talked about upper airway, we talked about lower airway, and we're getting into the tracheobronchial tree now, about how long it is, how wide it is, those things like that, okay? All right, the tracheobronchial tree functions for air conduction. Now, we don't have food conduction anymore. By the time we get down to the tracheobronchial tree, shouldn't be any food in here, right? Shouldn't be any more food particles this far, all right? There should be only air now, okay? We got air that's being conducted or directed to the land of the parenchyma, okay? It is lined with pseudostratified ciliated columnar epithelium. Now, who can tell me what ciliated means? Ciliated. What is that? No. Anybody know what ciliated means?
It has cilia.
Yeah, it has cilia. Who can tell me what cilia are?
Little hairs.
What is the cilia? Say it. Say it again.
Little hairs.
Little hair-like structures. The cilia are like hair-like structures that are lined the tracheobronchial tree. And those hairs move the mucus blanket up the escalator, okay? It moves the mucus blanket. Now you're gonna learn that mucus blanket has 2 layers, and you're going to learn what those layers are. But what it is guys, when you are smoking cigarettes or just breathing, period, the particles that don't get trapped in the nose hairs, they still keep going, but they get trapped on the gel layer of the mucus blanket, and it traps all those little foreign pieces of smoke, dust mites, all that kind of stuff gets trapped all through your tracheobronchial tree. And what happens is the cilia are little hair-like structures that rise up out of the skin, out of the surface of the cells, and they move in one direction. They beat like seaweed. You ever seen seaweed move with the ocean? Well, that's what the cilia are doing. They move, and they are moving that blanket of gunk and junk up to the mouth so you can cough it out. Okay, that's when you get that sensation. Right, when you get that sensation to cough, it's because those cilia have moved that junk up to the large airway for you to cough it up and cough it out. Okay, that's why you've heard of somebody, you might have heard of smoker's cough, or somebody who every time they wake up they cough for the first 10 minutes of life. Right, they wake up and they have this coughing spell for about 5-10 minutes, and then they finally clear it. Okay, well, that's because, Talisha, why are you laughing?
And you just be a little comical sometimes.
Oh, okay. All right. So yeah, when you are smoking and you have all that gunk and junk, when you smoke cigarettes, the cilia become paralyzed. Okay, they can't move. So the mucociliary blanket, that mucus blanket, is sitting still. All right. And somebody who smokes, they usually smoke all day long, right? And so as long as they're smoking, it's paralyzed, right? It's paralyzed. So the mucus blanket is just sitting there. But what happens when they go to sleep? When a person finally goes to sleep, are they smoking? No. So when they stop smoking, the cilia say, hey, he's asleep, let's move, right? And so they wake up and they start beating while you sleeping. And when you wake up, all of that mess is right there at your throat. You wake up again, all the mucus blanket and then the gunk is right there, and you feel it. So they wake up and they cough, they spitting up stuff and do all that kind of stuff for about 5-10 minutes, and finally clear it up. And then they grab a cigarette and smoke again. Okay, when they do that, it's paralyzed again for the whole day. So that's why they call it a smoker's cough, because the cilia come back to life when they go to sleep. Okay, all right, so the cilia are part of the cells now. When we're getting down into this area, it's ciliated. That means it has cilia in it. All right, now the layers of the tracheobronchial, further down the tracheobronchial tree, it says you have a cartilaginous layer. You have the lamina propria, which contains the vessels and the nerves. And then you have the epithelium. So it's like 3 layers of the actual tracheobronchial tree. You got a cartilaginous layer for the cartilage. You have the lamina propria, which kind of contains the vessels and nerves. It's kind of muscular a little bit. And then you have the epithelium, which is the actual layer of it, the top layer, right? The epithelium. And we're going to show pictures of the layers. You'll see those layers. All right. But then we start with the trachea, which is generation what? 0. The trachea is considered to be generation 0. This is before it starts to bifurcate, because all those bifurcations are generations, right? And we don't make y'all memorize all the generations, but I do want you to know that the trachea is generation 0. All right. How long is the trachea? 4.5 to 5 long, or 10 to 12 centimeters. Okay. That's why you got to know centimeters and inches and how to convert them, because the answer may say the trachea is approximately how long, and the answer may be in inches, it may be in centimeters, right? You got to know both in order to make sure you get it right. Okay, they may say, or they may have it backwards. They may say the trachea is 4.5 centimeters, and you thinking about 4.5. Oh yeah, that's it, right? That's wrong. It's 4.5 to 5.5 inches, or 10 to 12 centimeters long. That's how long the average adult trachea is, about 10 to 12 centimeters long. Not that long. All right, let's see how wide it is. It's approximately 1 inch in diameter, or 2 to 2.5 centimeters in diameter. So diameter, of course, is the top. How wide is the hole, right? The diameter of the vessel itself is about 1 inch or 2 to 2.5 centimeters. All right. What about the C-shaped rings we talked about? How many C-shaped rings does it have, or the average trachea have? Huh?
16 to 20.
16 to 20 C-shaped rings. How many full rings does it have? 1.
1.
That's called the cricoid. The cricoid. So it has 1 complete ring called the cricoid and 16 to 20 C-shaped rings. We already talked about the location of the trachea. We said the trachea was anterior to the esophagus, which means it's in front of the esophagus. The trachea has ciliated, pseudostratified columnar epithelium. And it divides at the carina into 2 main stem, I said stream, I should be main stem. No. Oh, that's what happened. 2 main stem bronchus. Now, don't be confused, because usually when they have a picture of it, they say bronchi, but that's because it's plural. The first bifurcation is the left and right main stem bronchus. But when we're talking about them both, we say main stem bronchi, right? Because we're talking about more than one. But that each individual one is the right and the left main stem bronchus. That trachea divides at a place called the carina into 2 main stem bronchus. The left and the right main stem bronchus. Just prevent collapse. All right. Now, the main stem, why does it keep going? I don't know why they did that. The main stem bronchus, both of those are generation 1. Generation 1 is so trachea generation 0, and then the main stem bronchus, that will be generation 1. Okay, you got a right one and a left one. And there are some very important differences between the two. All right. The right main stem bronchus is about 20 to 30 degree angle, which is less acute angle than the left one is. It's shorter and wider than the left. The right main stem bronchus is about a 20 to 30 degree angle. So that's what they're talking about. As it comes down off the trachea, it only angles off at about 20 to 30. So it's more straight, right? It's almost straight. It's just like a 20 to 30 degree angle where it bifurcates at the carina. It's shorter and wider than the left. So if a child is eating, or if a child is playing with a G.I. Joe or a little doll, a little soldier toy, and the head comes off of the toy and goes into his airway, which lung do you think it's going to be in? The right lung. It's going to usually be on the right because it's wider and shorter than the left, and it has a more straighter angle, right? So if he inhales that head, it's going to get trapped on his right side more than the left, because the left has a bigger angle. It's 40 to 60 degree angle, and it's smaller than the right. So 9 times out of 10, if you aspirate, that's what aspiration is. When you aspirate is when you inhale something other than air. You can aspirate water, you can aspirate gastric contents like vomit, right? Or your drink that you're drinking real fast, you can aspirate it. If it gets into your lung, that's called aspiration. Okay? So if your child aspirates, or you aspirate, or some type of little toy or something gets trapped in a baby's lung, it's probably going to be on the right side because it has a straighter angle and it's wider than the left side. So let's look at the left. The left main stem bronchus is a 40 to 60 degree angle, and it's more acute. It's more acute angle. Smaller and longer than the right. The left main stem bronchus is structurally like the trachea, structurally similar to the trachea. And like I said, you don't have to remember all the generations. I just want you to know you started with the trachea, then you went down to the main stem, the right and left main stem bronchus, right? And now we're going down to the next structure when it bifurcates again, is the lobar bronchi. Lobar bronchi. Now, the reason we call these lobar bronchi is because these are the bronchi that go into the perspective lobes of the lungs, okay? The lungs have lobes. The right lung has 3 lobes, and the left lung has 2 lobes. All right, so let's show it here. Already on the board. All right, so this is the patient's left, right lung, and the patient's left lung. Okay? The right lung has 3 lobes: upper, middle, and lower. Right upper lobe, right middle lobe, right lower lobe. And the left lung has 2. It has a left upper and a left lower lobe. Now, the left lung also has a little small piece called the lingula. The lingula section. Right upper, middle, lower, and the left upper, left lower. And it also has a little section at the bottom called the lingula. Now, so what they're talking about is those, after the left and right main stem bronchus, you have your lobar bronchi, and they go into their respective lobes. So you got one that goes up into the right upper lobe, you'll have one that goes into the right middle lobe, and one that goes down into the right lower lobe. And then on the left side, you'll have one that goes into the left upper lobe and one that goes into the left lower lobe. Okay. With that video you just saw said superior, middle, and inferior, but that's the same thing as upper, middle, and lower. Okay. So let me look at my PowerPoint, see if my PowerPoint has a few of those pictures. All right, so we'll look at this one right quick. Are you seeing my screen? Some lungs? Okay.
No.
Okay, here I go. I'm gonna share my screen. All right, here we go. This is a pair of lungs. Huh? You're not seeing what's going on? You're not seeing my pictures? Okay. All right, well, we can fix that. What about now? Huh?
No, still.
Well, let me try this one. See it now? What are you seeing? It must be something with the internet. Yeah, that's what it is. When it does start doing that, that's the internet.
It's still black. Their name and nothing else.
Yeah, it says the internet is unstable. So that's what it's doing. It's a little internet glitch right now. Let me give it a little moment. Secure and connected is just. All right, let me try it again now. Let's see. Let me know if you see a picture.
Yeah. I see it.
All right. So this is a pair of lungs here. This is the right lung. This is a left lung. And this is how it looks. You have a right upper lobe, which is this, is outlined with the green. Right upper lobe, right lower lobe, and a right middle lobe. Okay? And on the left side, you have a left upper lobe and a left lower lobe. Now, this little section right here is called the lingula. It's not a lobe, it's just a little section called the lingula. When we talk about lobes, the left has 2 and the right has 3. Okay? Now, this is where you're going to start getting into some real having to understand and read, okay? Because each lobe has its own segments, okay? Because not only do we have the lobar bronchi, but we have segmental bronchi. So if you were looking at this right here, these little pieces, right? See how they look like little countries, right? How many segments would you think are in the right upper lobe?
3.
3. There's about 3 segments in the right upper lobe. You have the apical segment, you have the anterior segment, and I think posterior. I'm not sure, but we're going to learn them. And then the right middle lobe has its own segments. The right lower lobe has its own segments. You're going to have to memorize each lobe. Okay? When I ask you in your oral questions, they're going to say, name the segments of the right upper lobe. You got to be able to name them. Okay? Or name the segments of the left lower lobe. You'll have to be able to name them. All right? So that's what that is. But this is how the lobes are configured. Okay? Go back to the but like I said, you're gonna learn more about that when we get to it. I just want to show a picture of it. And then also in your book, don't forget, we in page what? What's the pages I said for this one? Is it 9 and 16? 9 and 16. So you need to look in your book, chapter 9. Yeah. You look in your book, chapter 9, it's great pages. I mean, great pictures and explanations of the lungs and the trachea. Nine and 16. Yeah, that's a baby's baby circulation. We won't be dealing with that one when he's in your stomach. All right, look at page 162. If you look at page 162 in your Egan's book, there's a picture up there that looks like this, showing you that first bifurcation. 162. It's showing you the angle, right? The big one is the adult, and the other one on the right is the infant. We're not worried about the infant, but I want you to look at the adult trachea. That first part is the trachea, and it bifurcates into the left and right main stem bronchus. Notice that the right side is about a 20-degree angle, right? It's about a 20-degree angle. So it's more straight than the left one. And the left one is 40 to 60-degree angle. This says 40 to 50, but 40 to 60-degree angle on the other side. Okay? So that's talking about showing you the difference in those main stems. And there was another one I wanted to show you what I want to talk about right quick. Look at page 190. No, 192. 192. If you look at page 192, this is when we start getting into the lobes and the segments. These are the lobes and the segments. If you look at the trachea, I guess I'll show it this way to make sure we all at the same place. This is the trachea, right? And it bifurcates at the carina into the right and left main stem bronchus, right? Right and left main stem bronchus. All right. And then after the right main stem bronchus, it bifurcates again into the lobar bronchi. The lobar bronchi. Those are the ones that go into their respective lobes. Okay. After it goes into its respective lobes, it's going to bifurcate again and become segmental bronchi. And they go into each individual segment. So these colors that you're looking at are segments, right? Like over here, it's showing you. Look at the one on the, let's say, at the top on the left-hand side. It's showing you that the right upper lobe, because it's the right, and then on the other side is the left. It's got the anterior view. Look at the picture that says anterior view. The right upper lobe has 1, 2, 3 segments. See that? The right middle lobe has 2 segments, 4 and 5. And then the right lower lobe has the rest of them. You can see them in the back. You can't really see them in the front, but if you look on the other side, you can see them in the back. That's the posterior view. All right? This is showing you guys that those bronchi, they go up into their respective lobe, and after they get into the lobe, they branch off again into their own segment. Okay? Their own segment. And that's called segmental bronchi. All right? Let's keep going.
Mr. McCarthy, the posterior view of the right lung is supposed to have how many sections?
The right lung has 3 lobes. Right upper, right middle, and right lower. Now, the posterior view, you don't see it like you do on the left side. The anterior view or the posterior view looks different for the lung. You can't see them all from both views, right? So if you look at the left-hand side, that right lung, you can see the 1, 2, 3 lobes, okay? It's right upper lobe, right middle lobe, right lower lobe. And you only see one segment from this view, but over here you can see the right lungs, the right lower lobes segments from the back. They're in the back. Okay, if you turn the lung around, you will see it from the back. This is showing you the posterior view and the anterior view and the posterior view of the lungs, looking at the segments. Okay, that's what it's trying to. Okay.
Okay, now I was confused about where the lobes were, but now I think I understand what you're saying about you seeing it from the posterior view.
So these colors are not lobes. The lobes are the sections. Those colors, all those different colors are the segments. Okay. It's kind of like a house. If you have a house, right, you go into the house, you have a left side of your house and you have a right side of your house, right? And then when you go into your left side of the house, that left side has individual rooms, right? You got this room, bathroom, kitchen, right? Those individual rooms would be the segments, okay? Think of it like that. You got a lung that has a lobe. You got a right upper lobe, right lower lobe, right middle lobe. Right here. This is where the white is. This is separated. 1, 2, 3, these are the right upper lobe. 4 and 5 is this section here. That's the right middle lobe. And this 8 one down here, this is the right lower lobe. But each one of those lobes have an individual segments. The right upper lobe has 1, 2, 3 segments. The right middle lobe has 2 segments. And the right lower lobe has, I think, 5. You can only see one from this view, though. You turn it around, you can see the rest of them in the back. Okay? All right. Now, so we talked about the how they look. We're at the lobar bronchi. The lobar bronchi are the ones that go into their respective lobes. So this is what we just said. On the right hand, it has 3 lobar divisions, which are the upper, middle, and lower. And then the left main stem bronchus divides into 2 lobar bronchi, which because they only have 2 lobes on the left, right? You got one of them going up into the upper and one of them going into the lower, right? Now, when they get into their respective lobes, they branch off again into their respective segments of that lobe, okay? And here are the segmental bronchi that you have to memorize. You have to memorize. That's why I got it highlighted. And it's a lot, guys. That's why I said a lot of people find different ways to memorize them. Songs, we coming up with all kind of stuff to memorize them. But these are the segments of the lungs. Each segment has its own, each lobe has its own prospective segments, okay? So first, let's look at the right upper lobe. We already said that the right upper lobe has 3 segments, the apical, posterior, and anterior segments. The right middle lobe has 2 segments, the lateral segment and the medial segment. The right lower lobe has 5 segments, superior, medial basal, anterior basal, lateral basal, and posterior basal. Now, that's all of the segments on the whole right lung. So how many segments are in the whole right lung? 10. You got 3 in the upper, 2 in the middle, and 5 in the lower. It's very important. The reason why we're learning this, guys, is because what if mucus gets trapped in my lateral segment of my right middle lobe? I got to know how to position the patient to drain it. Right? As a therapist, you're going to be doing posterior drainage, which is chest physiotherapy. That's going to be when you're turning them in order to let that stuff drain into the larger airway so they can cough it up. Because sometimes those secretions and mucus gets trapped, right? It gets trapped into those segments. And you have to sometimes use a vibrator. You have to use your hands and do what's called percussion, right? And you beat it out of them, okay? And so that's a different therapy that you're going to have to do. We have a vest that we can put on and it shakes the whole body, right? We have airway clearance devices that they can blow into or inhale into, and it does things to the lungs, vibrates the lungs, flutters the lungs, all kind of stuff, guys. It's your job. This is bronchial hygiene, right? That's part of your therapy as a respiratory therapist, is to clean them lungs out. So if the doctor says, okay, Mr. Johnson, I got an x-ray and he's showing some loculated mucus in his superior segment of his right lower lobe. I need you to drain that for me. You're like, okay, doc. And then you'll go to his room and tell him how to lay, right? You need to either lay supine. He's either going to have to lay prone, semi-Fowlers, lateral, Trendelenburg, right? You're going to learn those positioning. Those are terms you got to learn, right, of what that means. Okay, we're going to learn that. But that's all to say, you got to learn the segments first. Okay, you got to know where they are, because if you don't have no idea where that segment is, you won't have no idea how to drain it and do your therapy. Okay, so you're just in the way. All right, so that is the segments of the segmental bronchi of the right lung. The right upper lobe, you have those bronchi that go up into the apical. One goes into the posterior, one goes into the anterior. On the right, at the right middle lobe, you have one that branches off into the lateral segment, and then one will branch off into the medial segment, okay? And the right lower lobe, you have one that branches into the superior, one to branch off into the medial basal, anterior basal, lateral basal, and posterior basal. Got to cover the whole lung, because you got to we still haven't gotten to the magic. We still up in the conducting zones. We haven't even got to the magic yet, right? Okay. Now let's look at the left. The left lung has 2 lobes, left upper lobe and left lower lobe. These are the segments of each one. The left upper lobe has an apical posterior segment, an anterior segment, superior lingula, and inferior lingula. Those are the sections or the segments of the left upper lobe. And then the left lower lobe has 4 segments: superior, anterior medial, lateral basal, posterior basal. So how many segments does the left lung have? 8. How many segments are in your lungs completely? 18. 10 on the right, 8 on the left. Right? So if I said, Brittany, tell me the segments in the left upper lobe. That is an oral question. All of these lobes have that question as an oral question. It's in that stack, so you never know if you're going to pull it or not. It's going to be your turn. You're going to pull it. You're going to say, oh, tell me the segments of the left upper lobe, or tell me the segments of the left lower lobe. Tell me the segments of the right middle lobe, right? You got to be able to answer those. So you got to know them. right. So let me look in my book again. I want to see if I can find another page. Make sure you're looking in your book, guys. You're reading so you can really understand how these segments work. Just touching the ice. So 9 and what? 16? Let me look at 16. 9 and 16. That's going to be more just assessment. Inside assessment. Yeah. All right. So you need to work on these tonight. Make sure you understand, you study on these segments because it's a lot of what you learned so far. We haven't gotten to the magic yet. We started with the upper airway and now we are down to the segmental bronchi. Okay. So you got to, just like the blood flow through the heart, you got to know the conducting zone. You got to know every structure of the tracheobronchial tree. So we start with the trachea. Okay, and then we bifurcate at the corona to the left and right main stem bronchus. Then the bronchi, which are lobar and segmental. Then the bronchioles, terminal bronchioles. Then the respiratory bronchioles. And that's where you find the parenchyma, which is the magic land and the alveoli. Okay, all right, so everybody should be able to do that. I'm going to say it one more time, and then I'm going to ask you to say it. What is the steps of the tracheobronchial tree? All right. Start with the trachea, left and right main stem bronchus, then the bronchi, bronchioles, terminal bronchioles, and then respiratory bronchioles. That's it. That's it. All right, so Cassidy, tell me the steps.
You start with the trachea, and then you go to the main stem bronchus.
Okay.
And the lobar bronchi, and then the segmental bronchi, and then the terminal bronchioles,
and then terminal bronchioles.
And then terminal bronchioles.
And then respiratory bronchioles.
And then respiratory bronchioles.
Okay. So it's trachea. Now you guys don't have to tell me segmental and lobar. When you say bronchi, it's just the bronchi. That's fine. It's trachea, left and right main stem bronchus, then bronchi, then bronchioles, terminal bronchioles, and then respiratory bronchioles. That's the steps. Okay, everything to the terminal bronchiole is just conduction. Gas exchange or the magic does not happen until we get to the land of the parenchyma, which is the respiratory bronchioles. Okay, all right, Brittany, how does it go? Okay, bronchus. Okay, bronchi. Bronchioles. All right. Make sure y'all saying it right. All right, Miss. Let me see who else. I see with the cameras. Nobody has the camera on, so I really don't know who's here. But Lori, tell us, Lori, the steps. Okay. Bronchus. Bronchi. Bronchioles. Terminal bronchioles. Respiratory bronchioles. Good. All right. If you're still with us, please cut your camera on so I can know who's here when I ask questions. Only have one. Okay, there we go. All right. Kelsey, Kelsey, tell us the steps.
Okay, you start with the trachea into the left and right main stem bronchus,
There you go.
into the bronchi,
Yeah, bronchi, good.
into the bronchioles,
Bronchioles,
into the terminal bronchioles,
terminal bronchioles,
into the respiratory bronchioles.
respiratory bronchioles. Michaelin,
You goes from the trachea to the left and right main stem bronchus to the bronchi to the bronchioles,
bronchioles,
then the terminal bronchioles,
terminal bronchioles.
and then the respiratory bronchioles.
Alicia,
Sorry, I'm coming. So you start with the trachea,
okay,
and then you go to the left and right mainstream bronchus,
okay.
and then is it called the lower? I can't really understand my note. Is the lower bar bronchi?
Yeah, just say bronchi.
Bronchi, okay. And then to the segmental bronchioles.
No, bronchi. See, the bronchi, guys, are two different ones. You got segmental bronchi and you have lobar bronchi. When I'm asking y'all to do this, just say bronchi. That'll will count for both of them. So you have
Okay.
We'll start back with the trachea.
Okay, trachea, left and right mainstream bronchus.
There you go.
And then you go to the bronchi.
Bronchi, good, okay.
Into the bronchioles.
Bronchioles.
Into the terminal bronchus.
Terminal bronchioles.
Terminal bronchioles.
Okay.
Into the respiratory land of
parenchyma, which is the
parenchyma.
That's the respiratory bronchioles.
Respiratory bronchioles.
The respiratory bronchioles is the land of the parenchyma. Okay. That is the land of parenchyma. All right, Heather. Okay. Good. 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 Hello. What's up? I'm at work. What's up? Hold on. Okay, Shatara. What's up, man?
You start at your trachea and go to your left and right bronchioles, to your bronchi, to your bronchioles,
okay,
to the terminal bronchioles,
good,
to respiratory bronchioles.
All right. All right. Let's see who else got that. Oh, Stephanie. Go ahead.
Okay, you start at the trachea and then you go to the left and right mainstream bronchus.
Okay.
Bronchi to the bronchioles, to the terminal bronchioles, and then to the respiratory bronchioles.
Excellent. All right. Christian.
You start at the trachea, and then the left and right main bronchioles,
Bronchus,
then the bronchia, then the bronchioles, then the terminal bronchioles, and then the respiratory bronchioles.
The respiratory bronchioles. Okay. So don't forget, after the left and right main stem bronchus, it's the bronchi. Okay. Bronchi. And that bronchi are both the lobar and the segmental bronchi. That first set, the first bronchi branches into the prospective lobes, right, which are the lobar bronchi. They go into the lobes of the lungs. And after that, that bronchi branches off into segmental bronchi, which go into each individual segment inside that lobe, okay? Then it gets smaller and turns into the bronchioles, then terminal bronchioles, and then finally respiratory bronchioles, where we get to the land of the magic, which is the parenchyma. All right, Jessica, can you talk? What about Maria? Can you talk? All right. Anybody that I didn't call that's here? All right. Good. Good. Let me see what's next. Let's see if I'm going to go into it or not. Now, yeah, so we got to learn these segments, guys. Can't play with them. I expect you to learn those segments tonight as much as you can. Now, you're not going to memorize them totally tonight, but you should be really close. You need to focus a whole lot of attention on these because these are questions. There will be questions on the exam that says all of these segments are part of the right upper lobe except, right? So you got to know them to know which one should be there and which one should not be there. All right, you've got to learn these. All right. All right. So let's finish up these steps we just said. So we talked about the right and left main stem bronchus, C-U-S, bronchus. Then we went into the bronchi, right? And we talked about all of the segmental bronchi. Now we are in the bronchioles. Bronchioles. Now, the segmental bronchi, guys, look how small they're getting. The diameter is 1 to 4 millimeters. 1 to 4 millimeters. What's the diameter of the trachea? What was the diameter? The diameter, the size of the hole of the trachea is what?
1 inch.
1 inch. The diameter of the trachea is 1 inch in diameter. Well, how many centimeters is 1 inch? Yeah, there you go. So 1 inch diameter for the trachea, right? But then look, when we get down to the segmental bronchi, they drop down to 1 to 4 millimeters. That hole is only 1 to 4 millimeters. Then what about the bronchioles? The bronchioles are less than 1 millimeter. The hole in the bronchioles is less than 1 millimeter, and we still haven't gotten to the magic. So you got to think what you're putting in your lungs, because those, you don't have a lot of real estate, guys, to play with. Okay, that's a real, you can't even do that with your finger almost. Less than 1 millimeter of diameter is extremely small, but you're sitting here breathing without a problem, right? Most of us are breathing right now and not short of breath, but just sitting here, right? But you only have a small amount of play when it comes to, if it closes up on you, you through. So it's very important that you watch the smoking and being around smoke and all that kind of stuff. That's why people have asthma attacks and hyper reactive airways, because you don't have a lot of space. That big old trachea is not what's breathing for you. It's these small bronchioles and these terminal bronchioles. So bronchioles are less than 1 millimeter, right? They have no connective tissue, have a decreasing number of goblet cells, which we'll learn what those are tomorrow. But they're less than 1 millimeter. And then we get to the terminal bronchioles, which is the last step of the conductive airway. Terminal bronchioles is the last stop before we get to the land of the parenchyma. How large is the diameter of the terminal bronchiole? So it's about 0.5 millimeter in diameter, and we still haven't gotten to the magic. Now, the terminal bronchiole is about 0.5 millimeter in diameter, made up of cuboidal epithelium to squamous epithelium, which is not that important, but it contains Clara cells that may secrete mucus and surfactant. Clara cells secrete surfactant, and you'll learn what surfactant is on tomorrow. But it's the end of the conducting airways. The ends of the conducting airways. Now, these terminal bronchioles have what's called canals of Lambert on them. Canals of Lambert are communication portals from the bronchioles to the alveoli. Okay? The Canal of Lambert are communication points for the alveoli and the bronchiole. I'm going to show you that. We're almost done. All right. So when we get down to the terminal bronchioles and respiratory bronchioles, right? We have little holes here. There's little holes there that allow the terminal bronchiole or the bronchioles period to communicate with the alveoli. So if I have some alveoli that are starting to form, right? So let's just say this is a respiratory bronchiole, because the respiratory bronchiole and the terminal bronchioles both have it. But we're going to talk about the respiratory bronchiole. It has these little holes right here where these alveoli start to connect to. This little hole is called the canal. Canal of what?
Lambert.
Yeah, let me make sure I'm spelling it right. It's on camera. Canal of Lambert. The canals of Lambert are communication points between the bronchiole and the alveoli. These little holes, they're like little holes right there on the actual bronchiole. And this is where the alveoli can communicate with the bronchiole. Okay? Canals of Lambert are communication points between the bronchiole and the alveoli. Okay, that's different than what another canal that we're going to talk about. But this canal is called the Canal of Lambert. And the Canals of Lambert is a point in which the bronchiole communicates with the alveoli. The communication between the bronchiole and the alveoli at a place called the Canals of Lambert. Canals of Lambert. Then finally, guys, we get to the land of the magic, which is the parenchyma of the lungs, also known as your respiratory bronchioles. The purpose of the parenchyma of the lung is gas exchange between the alveolar air and the blood. That's the magic. Okay? That's the magic.
How do you pronounce that word? The C-U-B-O-I-D-A-L?
Cuboidal. That's the magic. The parenchyma of the lung. Parenchyma. That's when you get off at the terminal, guys, you step off into the land of the parenchyma. Okay? That's where your alveoli are and your respiratory bronchioles. Okay? The whole purpose of the parenchyma area is gas exchange. Gas exchange between the alveolar air, which is the air you breathe in, and the blood. That's where the air from outside gets into the bloodstream. The only place it can get into the bloodstream is in the parenchyma. Okay? Not in the trachea, not in the left and right main stem bronchus, not in the bronchi, not in the bronchioles, not even the terminal bronchioles. But when we get to the respiratory bronchioles or the parenchyma of the lung, that's when that gas finally gets to go into the bloodstream. That's when it's finally able to get into the bloodstream, when it gets to the parenchyma. All right? Like I said, you don't have to memorize these generations, but you know that at the respiratory bronchioles, gas exchange is beginning to occur. Just generation 0. All right. Now, let me see where I'm at now. Yeah. All right. So the parenchyma of the lung. Now, that's where I'm going to stop with this, because tomorrow I don't want to go into alveoli and then not have the time that I want. I'm going to stop here at the parenchyma of the lung. We've made it a long way. Okay. We've made it a long way down the magic school bus to the land of the parenchyma, which is where the magic takes place. We made it, and now we're going to talk about the alveoli tomorrow. So tomorrow when you come, we're going to talk about, first thing, we're going to get into the alveoli. All right, get into the alveoli. Now, tonight, homework for tonight will be homework number 1 in your Pulmonary A&P homework packet. Do homework number 1 for your attendance for today. I'll put it in there and you can upload it and submit it. Don't forget, if you failed yesterday's test, you need to start working on that one as well, that cardiac A&P practice and review. Okay? Cardiac A&P practice and review, start working on that. Now, that's not full grade and it's not due until you take the next test. But it's a lot to it, so start working on it. So while it's fresh on your mind, you can, oh, okay, I see why I missed that. Oh, okay, now I understand it, right? Because if you wait too late, it's going to be gone. And when the final comes, you're still not going to know it. All right?
This is the homework, right?
Huh?
This one's the homework, right?
Does it say homework number 1? I can't hardly see your screen. Does it say number 1?
Yeah, it does. It just didn't say pulmonary on there. I was just making sure.
Yeah, look up in the corner, the right-hand corner. Does it say RT210C?
It does. My bad.
That's all right. It's kind of small. But yeah, that's number 1. Do that one tonight. Should be fun doing. It's not a big deal, but that's what's going to be your attendance homework for tonight. All right. We have gone from the upper airway and the nose all the way down to the parenchyma. Tomorrow, we're going to talk about that magic land of the parenchyma where the alveoli are and how gas exchanges back and forth. What type of cells are in the alveoli? There's some special cells. They have 3 types, type 1, type 2, and type 3. And each one has a special function. So tomorrow we're going to talk about that, how many alveoli we have, and we'll continue on with the lecture, okay? It's a lot to pulmonary A&P. Not only do you do that homework tonight, but start really trying to use note cards and learning those segments. That's going to pull you a long way. You'll learn that, and I've seen that students that memorize those segments go farther when it comes to pulmonary mechanics and all of that, because that's the foundation of the lungs, is knowing those segments. Because if I have trapped secretions in one of those segments, I got to know how to get them out. We're going to learn, how do I lay my patient? Do I lay him on his side, back, head down, head up, prone on his stomach, stuff like that. You got to know. All right, so that's very important. Learn those. And now look, let me show you this one thing I want you to watch tonight. It's a real quick video, but it's called Dr. McNally's segments. Okay? Dr. McNally's segments. Number 1 for the homework. Yeah. All right, here we go. Let me show you this right here. In our module, there should be a video called Dr. McNally's segmental video. I want you to watch that tonight, because it's a really good video to understand the trachea. He has a trachea in his hand, and he shows you the different segmental bronchi that go up into their respective segments, and helps you learn how to see them. Okay, let me see. Here it is. My internet active. Okay, right here. See that? McNally's segmental bronchi video. Right here. Go to it and watch it. Here it is right here. Damn, it keeps moving. Right here. McNally, which is in our module, the one you in now. Dr. McNally's segmental bronchi video. Go to that and watch it tonight. And it will help you learn those segments. I promise you. We'll probably watch it again tomorrow as we talk, but you need to watch that, and you'll probably watch it several times so that you can memorize those, because you're really going to need them when we get to pulmonary mechanics and CPT and all that. You're going to remember. You're going to have to remember that. So watch that tonight and do homework number 1, okay? I will see you guys tomorrow at 1. I only had 3 people came to class today, so today was opened up for what? Was it alpha student? Alpha students. So tomorrow's open for omega students to come in person learning. But if you're an alpha student and you want to come as well, you might as well come on, because I don't really have people even showing up. All right. All right. If there's nothing else, I will see you guys. I will put the homework in and this lecture. As soon as it loads up, I'll put it in. I'll put the lecture in there for the submission part where you can submit it. And I'll see you tomorrow.